Okay, so the first question we're going to take a look at is a law of sines problem. And it's going to be looking at whether we either get a 2 solution or a no solution. First, just looking at the table, what tells us that this is law of sines? Just by the table. Yeah?
Because there's no full row filled in.
So the fact that there's no full row, it does tell us something. Something else we want to focus on, though, when we're determining if it's law of sines, besides that we have a row that's completely empty. We also have, yeah?
One entirely full row, and
Yeah.
one row with one piece of information and one blank.
Right, so we have a row that's completely full. That's the important thing, because that means we know an angle and we know a side across from it, which directly tells you it's law of sines. I guess if you had a fully empty row, it would be impossible to have a side, because you couldn't have that. And it would also be impossible to have side, angle, side. So I guess if you have an empty row, that indirectly tells you it's law of sines. Okay. All right. What do we have to find first? There's no choice about what we do first. Yeah? Yep, got to do alpha first. So we're going to set it up using our law of sines proportion. And what could I put on the left-hand side using the information from the row that has everything in it? Yeah.
Sine 38 over 12.
Perfect. Sine 38 over 12 equals, and then Cole would go on the other side.
Would it be theta or alpha over 16?
Sine of alpha over 16. Good. Now we want to get sine alpha by itself, so the easiest way is just multiply by 16. If you cross multiply, you're going to have an extra step. So I would say just multiply by 16. So that's going to give you 16 sine 38 over 12 equals sine alpha. And then what's our last step to get alpha alone? Yep. Yep, we're going to take the inverse sine on each side. Now, what's going to happen in this step will determine whether we have 2 solutions or no solution. All right. If this problem, when we type it in, comes back with an error, then this is a no, either you made a mistake or it's a no solution. Remember, if this is bigger than 1, you're going to get no solution. So we can check it, and this doesn't really waste time because I can use all this to still type it in a second. Okay, it's definitely less than 1, which means I have a solution. Okay, so let's do the inverse sine of what I just typed in. Okay, so one solution I get is 55.173. And that's for alpha. Now, 55.173. Okay. What do I do with the 55.173 to find the potential second answer? Yeah.
Add 38.
Add what?
38.
Add 38. No. Subtract that from, yeah. Subtract that from 180. So minus 55.173. That gives me a potential answer of 124.827. Now, how do I check if that answer fits in my triangle? Yeah.
Add 38.
Right. Take the angle that you think that's the second answer, add it to the one that was given, and make sure that you are under 180. If you add 124.827 and 38, will you be under 180? Yeah. So that 124 is definitely a second answer. And now we want to go like this. alpha 1 and alpha 2. Is it 124? Yeah. Okay, now if alpha has 2 answers, then that also means what? Yep.
Everything else is 2 answers.
Everything that you need to solve for has 2 answers. All right. What are the 2 angles? Because now we have 2 out of 3 angles in both answers. What are the 2 angles we would add together and subtract from 180 to get gamma 1?
I didn't get a question.
Cool.
Would you add the 55 173 and the 38?
Yeah, perfect. You're going to take the 55,173, and you're going to take the 38, and you're going to add those up and subtract them both from 180. Okay, so I'm just going to subtract them one at a time like this. It's the same thing. 180 minus the 55 minus the 38 gives me 86.827. All right, now to get gamma 2, what are the 2 angles I'm going to add up? And then subtract from 180. Yep.
Yes, use the 124.827
Yep.
and the 38.
Exactly. Take 180 minus 124.827 and minus the 38. If you got this far and you all of a sudden you get a negative answer for this, then that means you messed up counting the second solution and you shouldn't have. All right. So if that ever comes out negative, you somehow made a mistake and you should not have done the second solution. Right. But we got a positive as we already checked it should work. 17.173. Okay, so now we've got all the angles. We're done with that. Last thing we need is the sides. What row are we going to use for C1 and C2? We use the same row for both. Yeah?
Beta.
Which one?
B.
Yeah, row B. Yeah, row B. Because that row was given and we know that it's right. And there's no decimals, so that's always nice. Okay, so to find C1, we're going to do sine 38 over 12. And to find C2, we're also going to do sine 38 over 12. But what's going to go on the right side when we are finding C1? Yeah.
Sine 88.827 over C.
Sine 86.827. And you said over what?
Over C.
Can you be more specific?
C1.
C1. Yep. And how about when you set it up for C2?
Sine 17.173 over C2.
Sine 17,173 over C2. Okay, so I'll do the top one. Okay, let's just cross multiply on that and see what we get. So you're going to have, make sure you're in degrees, 12 sine 86.827 divided by sine 38. Just be careful with your parentheses, just like I did. Okay, so that gives you an answer for C1 of 19.461. And you would do C2 the same way, cross multiply. All right, so the next problem is going to involve a different law, so not law of sines, law of cosines, and it's also going to involve a word problem. Okay, so there will be one word problem on the test. There will be law of sines or cosines, one or the other. So for this one, it says that you've walked from point A to B, and it's 200 feet, and then you turned, at least the way I'm interpreting it, you turned 80 degrees, and that's this angle outside there. That's where they labeled it. So that's 80 degrees, and then you walked 170 feet towards point C, or 100, well, I guess we need to pick which number we want to use. Let's make it 160, because that's what it says in the diagram. Oh. All right, so it's 160 feet. And now find the length of AC. All right. So I'm going to call this side X. We've already used A, B, and C for other letters, so I don't want to use lowercase a, b, and c here. All right. What's the first thing we need to figure out inside this triangle so that we can use the law of cosines? Yep.
One of the angles.
Yeah, we need one of these angles. We don't have any angles inside the triangle, the way they've labeled it. So how could we figure out this angle inside here? Yep.
You could subtract 80 from 180.
Yeah, we could subtract 80 from 180, which would mean that angle is how much?
100.
Yep. So that angle inside is 100 degrees. Okay. Now, using our three letters, what kind of triangle is that? And that's going to tell us which law we need to use. Yeah.
Side angle side.
Right. It's a side, an angle between, and then another side. So side angle side is one of the two types that fall under law of cosines. And because it's side angle side, you have to do law of cosines twice. One time you solve for a side, one time you solve for an angle. So it covers everything that can happen. Whereas if I had given you a side, side, side problem, you're just solving for an angle and for an angle again. You're never solving for a side. Okay? And you need to know how to do both. Okay, so if we set up law of cosines, what would be on the left-hand side? We just have one thing over there, and then everything else is going to be on the right. So we got to be careful because in this problem, B represents an angle. So we're using different letters. No, not beta squared. So this is where we need to know the pattern of the law of cosines, not necessarily the exact letters you're using. Yep.
Would be C squared.
Well, C is an angle. So we're not, again, the letters are not going to match with the formula I gave you this week.
Gamma squared.
We don't have gamma in that picture. They didn't use any of the letters that I used this week, which is fine. We just need to understand the formula, not the labels. Yeah.
X squared.
Yes, it's going to start out x squared equals, and then what would we put on the other side? Yep.
200 squared minus 160 squared.
200 squared, and then what would come right after that?
Minus.
Plus, yeah, it's always a plus. 160 squared. Okay, then what would come after that? That's the minus. Yep.
160.
Yep, 2 times 200 times 160. And the last thing we need to put there.
Cosine B.
Cosine 100. Okay, so they didn't use any of the letters that I used this week. They used it as, this is from a different book or whatever it's from. So we just have to use the general formula following the pattern. Any questions on how to set that up? Okay, so now let's do out what we can. So we've got 200 squared, and then I'm going to add 160 squared. Gives me 65,600. Right, I've got 2 times 200, that's 400. 400 times 160. times 160. That gives you 64,000. Okay. At this point, we've really done as much as we can do on the right-hand side without rounding. So now we want to finish it off and get x alone. How would we get x by itself? Yep.
For both sides.
Yep. So square root both sides. Square and square root cancels out. And now, let's take that in and see what we get. So square root of 65,600 minus 64,000 cosine 100. Okay, so that, in theory, gives me a distance of 200, it was feet, right? Yeah, 276.972. Feet. Okay, so that is the distance across the lake. Now, they didn't ask for an angle in this problem, but I am going to do either angle A or C because you need to know how to use inverse cosine to get the angle. All right. But first, any questions on the side? All right. Now, let's see if we can find this angle right here. If I want to find that angle, how would my law of cosines start out? On the left side. So we're solving for this angle right here. And I want to know what I would put on the left side to find that.
160 squared.
Yep. So 160 squared equals, and what would I start putting on the right side? Yep.
200 squared plus 276.97 squared
276.972
minus 200, well 2 and then 200
So 200
and then 297.972. Did I say that wrong?
276, right?
Yeah.
That's
Yes.
what we have in the calculator, I hope. Well, I could have copied it wrong, but I hope not.
And then cosine of beta.
So remember, we're not finding beta. We know everything around angle.
Oh,
B.
cosine alpha.
And what are they calling it?
A.
A, yeah. So again, because this is from a different kind of book, they use all different labels, which is okay. But we just gotta keep it straight. All right, so we got one side squared equals the sum of the other two, minus twice the product of the other two, cosine of the angle across from the side that I started with. Okay. So now this is the other kind of situation that can happen. You're solving for the angle. All right, so let's do out what we can. So we've got 160 squared. That's going to give me 25,600 equals, and I am using something that's rounded, but I've got 3 decimal places, so that's okay. So 200 squared plus 276.972 squared gives you 116,713. 700, I don't remember the rest. 116, 713, 48. We'll call it 9. Put 489. Now I'm going to do 2 times 200 times 276 2 times 200 gives me 400 times 276.972. That gives me 110,788. Is it 0.8? 0.8, yeah. Okay, so not very nice numbers because we have a lot of decimals here. All right, I've got 3 steps left. What would be my next step to solve for A? Yep.
Subtract 116,000.
Yep, subtract that 116,713 from both sides. Okay, so let's see what we get when we do that. 25,600 minus 116,713.489. Okay, so that gives me negative 91,113. 489, and that's equal to, well, just to save ourselves a step, how could I move what's in front of cosine to the left at the same time? Yeah?
You divide the negative 1,107,088.8 and put that on the denominator, and then you take the inverse cosine of that whole thing.
Yeah, so let's divide by negative 110,788.8. That's also going to cancel these negatives. And the bigger number is in the bottom, which is always good. We don't want the bigger number in the top, because the next step, which we just said, is to take the inverse cosine. All right, so now let's take the inverse cosine of 91,113.489 divided by 110,788.8. So as long as we did everything right, that should be an angle of about 34.674. Okay, so that covers solving for an angle. The first part is how you solve for a side. Any questions on that? Okay, so let's take a look at this one. They've given us a complex number in standard form, and we have to convert it to trig form. In standard form, that's your x, and that's your y. So when you graph it, if you think of it like that, it's just like graphing the point 4, 6. Okay. What quadrant would I be in if I graph 4 plus 6i? And that's my real, and that's my imaginary. Yeah. Yep, I'd be in quadrant 1. Okay, so I would go 4 to the right and 6 up. Okay, so yeah, we said 4 to the right and 6 up, which is quadrant 1. All right, now we have to find the radius. So you want to pretend that that point is on a circle, just like that. All right. How do you find the radius of the circle that that point is on? Yep.
Pythagorean theorem.
Yeah, we're going to do Pythagorean theorem, where we make our triangle. That side's 4. That side's 6. So my radius in this case would be the square root of how much? Yep.
4 squared plus 6 squared.
So 4 squared plus 6 squared. And what's that going to come out to?
7 to 11.
it comes out to how much?
60.
So
And,
yeah,
Square root of 52.
square root of 52. Now there is a perfect square that divides into 52, so we should reduce that as much as we can. What perfect square goes into 52? It's not a big perfect square. Do you find it, Jim?
It's giving me decimals.
What did you try?
I tried root 4 squared plus 6 squared, and it gave me 7.211. And then I looked at root 52 and gave me the same thing.
So remember, we're trying to find a number in this list that divides into 52. We're trying to break down that square root as much as we can. Unless I'm not thinking right, but I think this number goes into 52. And you tried all those?
Well, like squaring each of those and
No, the 52 divided by 4.
it's 13.
Yeah. So it's 13. So when we break that up, it's going to simplify to 2 root 13. Any question on that? So you can, some people make like a factor tree to do that, but you've got to simplify that square root however you know how to do it.
So if I put in a decimal, that'd be wrong.
Yeah.
Okay.
Yep. No decimal. It's going to ask for an exact answer. Yeah. All right. So we got our radius. Now we need the angle. What's the formula for the angle when you are in quadrant 1? This formula is also shared with quadrant 4. Yeah.
Inverse tangent of y over x.
Yep, perfect. Inverse tangent of y over x. Now, if you are in quadrants 2 or 3, you would have to add something to that. What do you add to the inverse tangent of y over x in those two quadrants? 180 if you're in degrees, or what if you're in radians? Yeah. Pi. Yep. So it's going to be the inverse tangent. In this case, I'm going to do degrees. So my calculator is already in degrees. I don't need to add 180 because I'm in quadrant 1.
What is English for which quadrant?
2 and 3.
Okay.
So inverse tangent of 6/4 gives me an angle of 56.3. We'll call it 56.31. Okay, and those are the two things I would ask for on the test. I would not ask for the angle as an exact answer because there is no easy way to figure that out. But the radius as an exact answer, yes, definitely. All right, so let's look at this one. This one is the reverse of the problem we just did. They're giving us something in trig form, and we want to change it back to standard. Okay. So when I'm done, I want to have something that looks like this. I need to know what goes in those two boxes. All right. So what's the calculation I'm going to do to figure out the number in that first box? So to change that into standard form, what did you say we're going to have to do with the 7?
Multiply it to both terms in the parentheses, so
Okay.
7 times cosine 30.
Yeah, let's do it times the cosine 30, and that's going to tell me what goes in the first box. Before I even multiply it by the 7, I want to just figure out what cosine 30 is. If I multiply by 7 now, it's going to confuse me. All right, so let's just do cosine 30. We'll do the times 7 after. Okay. So if you do cosine 30, either you have to memorize it or use that number to jog your memory. What is cosine 30 as an exact answer? Remember, it's in the 30, 60, 90 right triangle. So the sides don't have any pies in them in the 30, 60, 90. They have square roots in them, but there's no pi. So it's something with square roots. Anyone remember what that is?
Root 3 over 2.
That's root 3 over 2. Yep. So root 3 over 2. And now, let's put in my 7 right there. So I'm going to multiply 7 times the sine of 30. Okay, sine of 30, if you do that out, you're going to get a half. All right. So now, when we multiply these two together, what's 7 times root 3 over 2 as an exact answer? Again, it's not really a lot we can do. Just
7 root 3 over 2.
yeah, just put it all together. So 7 root 3 over 2 plus, what's 7 times a half? Well, if you, as a fraction.
3.5.
How about improper fraction?
7 halves.
7 halves. Yep. There you go. And that's how you convert something into standard form. So you just distribute out the 7. If this had not been a multiple of 30 or 45, I would have just done decimals. Okay. But any question on converting from trig to standard form? Okay, so this problem, they're asking you to divide two complex numbers in trig form. If they were not in trig form already, well, I'd have two options. I could either divide them the way we've done before, which is using the conjugate. Then I got to deal with foiling and all the I-squared stuff. Or I could change them to trig form and then do it that way. This is already in trig form, so it makes this problem really quick. All right. So to divide z1 by z2, what is the calculation that I do to get my new radius? Yeah.
Divide 10 by 5.
Divide 10 by 5, so the radius in my final answer will be 2 cosine. And what do I do to get my angle in the final answer?
Subtract angles from z1 to angles from z2.
All right, and what would you get if you do that?
30.
30. So you do 40 minus 10, and you get 30. And if they ask you to leave your answer in trig form, you're done. If they ask you to convert your answer to standard form, then you have to do what we just did in the last problem. Okay. Any question on that one? Okay, so that's dividing. Okay, so the last question, they are asking us to find roots. We are doing a fourth root, which means we're going to get how many answers?
4.
Yeah, we're going to get 4. They're all going to have the same what? This is the same for every one of them. Yeah? Right. They're all going to have the same radius because they're all going to be on the same circle, but they're all going to be at different points on the circle. So that means the angle will be different. All right? So let's start by figuring out the equation we would need. So the first thing we need to write down is if you are trying to find the fourth roots of something, you write z to the fourth equals, and then we put our number on the other side. You know what? Just to make the radius a little nicer, I'm going to make that 5 a 4. It's just one less decimal we're going to have to deal with later on. Okay, so I changed it to 3 minus 4i. Okay. Now, what format is that? 3 minus 4i. Yep.
Standard form?
That's standard. We need to change it to what? Yep.
Trig.
We need it in trig form. Okay. We need both sides in trig form. Let's do the right side first. Okay. 3 minus 4i. What quadrant is that in? Yep. Quadrant 4. So it's right 3, down 4. There you go, right there. So 3 minus 4i. Now, we need to figure out the radius. What's going to be the radius for that triangle?
Or
What's the hypotenuse for that triangle? 5. That's why I changed the problem so it would come out. Okay, so radius is 5. Cosine plus I sine. Okay. Next thing I need is my angle. What is the formula that you use for your angle when you are in quadrant 4? Yeah.
Inverse tangent of y over x.
Perfect. Inverse tangent of y over x. So inverse tangent. Which number is y in this case?
Negative 4i.
Negative, just negative 4. Yeah. And which number is x? Yeah, 3. So it's an angle of negative 53 point. I normally would do 3 decimal places, but the next one's a 0. So let's do negative 53.13. Negative 53.13. Now, if they did not want that negative angle, what could you add to it to make it positive? I'm not going to worry about having a negative angle right now, though. But you could add...
360.
You could add 360. All right. We're not going to deal with that right now. So let's leave it like that. Okay, so we've got our angle. We've got our radius. And now, what do we change z to? We don't have a specific angle or radius for that. That's what we're going to solve for. Yep.
R
Okay, so we're going to have r to the
to the
fourth. And what's going to be your angle inside those parentheses?
4 theta.
Perfect. 4 theta. Yep, that's using de Moivre's theorem and changing to trig form at the same time. Okay. Now we need to set up 2 equations. What's going to be the equation I write down for the radius? Yeah.
R4 equals 5.
R to the 4th equals 5. And now we would solve that by getting rid of the exponent of 4. And how would I get rid of that? Yeah. Taking the 4th root. Not a nice number, so we're going to leave it like that. That is going to be the radius on every answer, the 4 through to 5. Okay, so that's half of what I need. What's the equation I'm going to set up for my angle? Yeah.
Theta is, 4 theta is 360 plus 50 for 13.
Say that again. 4 theta equals.
360 and.
Okay, I'm going to put that on the end. This is where we usually put that. Yep. And what did you say?
Nothing. It was
Okay. Yeah. So just negative 53.13. All right. So that's a formula for 4 theta. You want a formula for theta. So what do we have to do now to finish that up and get theta alone? Yeah. Divide both sides by 4. So we're going to get negative 13 point, I'm going to go to 3 decimal places now. Negative 13.283 plus, and remember, you're dividing this, and that. 360 divided by 4 gives me 90. Okay, so that is the formula that's going to generate all your angles in the final answer. You just have to remember that n is going to be what 4 numbers? Yep. 0, 1, 2, 3. All right. So now, when you write your 4 answers, you've got 4 through to 5, cosine of an angle, I sine of an angle. You're going to write that 4 times. Put it there, there, and one more time. Okay, so that's how your 4 answers are going to look. First number I want to let n equal is 0. If I let n equal 0, what will be my angle? Yeah.
negative 13.2.
Right, it's just the original angle.
Yeah.
It's negative 13.283. And each time, I'm going to add what to that? And that's how I'm basically going to get my other 3 answers.
90.
Yeah, just add 90 to it once, twice, and then 3 times. So your next angle is going to be 76.717. Your next angle is going to be 166.717. And your last angle is going to be 256.717. Now, if you did it again, what would happen is you would get a repeat. Like, wait a minute, what's 346 a repeat of? That's a repeat of negative 13. Because if you subtract 360 from that, that's the angle we started with. Okay? So those are your next 3 answers. 76, 166, 256. Yeah.
It looks like you got an extra 3 because the original angle was 13, but if you're just adding 90, then I don't know where it comes 76 instead of 73.
So when I had that negative 13, and then you add 90 to it, 76.717. Is that what I had the first time?
Yeah, it's just missing quite a bit.
Okay. And then just double check, add 90 again. Add 90 again. Those should be your 3 angles. 76, 166, 256. All with 717.